Good evening, everyone. Actually, I'm not doctor. I'm just student right now. I'm here to present my part of my study. I the effect of what we call a short-term electricity pricing forecasting using my proposed hybrid method on the Australian price market, which I select because Australian already deploy and solar rooftop PV in their grid already, many like a huge number of them. So I just briefly introduction from my institute. That's IAT was the first international institute of the postgraduate education in Asia. About students from 45 countries around the world. And I've started. This is my outline. So why short-term electricity for pricing forecasting is needed? So it shows the benefit to the utilities and customer side. So in utility side, it's maximize the profit in electricity market. So if we could 1% of the an error is equal to 300,000 US dollar per 1 gigawatt hour, 1 gigawatt peak load. And it's also encourage customer to modify their consumption to respond the price signal. So or we call like a demand response in customer side. In my research, so I have reviewed many papers, then I come up with the research question that is that the hybrid model is better than like a pure model. So one paper, let's say that ANN artificial neural network and ABC is better than ANN. So the objective of the study is to develop the algorithm to forecast the price and evaluate those algorithms on the half-hour ahead electricity pricing forecasting. So my methodology, first I collect the data for 2 months in this year. It start from the 2nd of January to the end of the February. So in ANN artificial neural network is the construction of the neuron layers, which are input layer, hidden layer, and output layer. Each connection layer assigned with weight, or we call like a connection weight, and bias, which is the constant value, is the additional neuron which is added to compute the next layer. So the output of this algorithm is the computed from the activated function. So in one paper, they optimize the connection weight using an ABC in the short-term demand in Turkey's market. So I also introduced the ABC artificial bee colonies, which is based on the PSO particle swarm optimization that consists of 2 types of bee. First is the scout bee that exploit the food source randomly with no reference. And next they use the worker bee to exploit with their local neighborhood, like their friends' information. After every bee go out to find the food source, they return to their hive and share information to their friend. So this is like the left-hand side is a scout bee. How they work with no experience set. They work with the randomly. And worker bee, they work under their friend experience or their friend information to achieve the global best food source. So maybe someone confused. This is I create that how I can travel from Bangkok to New Delhi with a minimum price or traveling time. In first time, in maybe first day, every particle randomly go by this way, and maybe next 25 days they share the information for their friend, and they could minimize cost or the traveling time. And after some day, the result is converged to the best. And for my proposed method, I use ABC to optimize the connection weight and bias of from the input. My input is a day of the week, time slot of the day. So I have a half hour price. So there will be 48 time slot per one day. So in load demand, I use the forecast demand and changing in demand from the previous time slot and historical price in the same day. For example, I want to forecast tomorrow at 8 o'clock price, so I use today 8 o'clock price and yesterday 8 o'clock price to evaluate my result. This is very simple to use the like a mean absolute error and mean relative error or percentage error. For the collecting the data price from 2 months, I collecting as supply, not supply, that I found that in some day the price is more fluctuate, more volatile in Monday, Thursday, Friday, Saturday. But in some case, some day the price is remain stable, not much fluctuate price. So I collect the data. Sometimes the price has higher, more than 1,000 US dollar per megawatt hour. So we call like this situation is a price spike. It will happen maybe sometime in the transmission constraint or unit shutdown or something like that. So the result, as I said, my algorithm ABC will optimize the connection weight and bias from show in this one. So this is the result from only ANN, and with my proposed algorithm, those B, 2 types of B, worker B, try to reduce the MAE or the error in the training data to be maybe a half, okay, from the $5.2 to $2.6 per megawatt hour. So after ANN is fully trained, then ABC help to improve their performance in the training process. So in training process, this is a graph. It's shown that the like a shading line is show the actual price, and the green and the blue we show in an ANN and ABC result. We see, let's see that in the ANN, the R-square value is about 0.8, but I use the ANN and ABC, the R-square is about 0.96, 0.93. So improve the correlate, maybe the result of R-square. So in forecasting process, it's shown here. It might be a little bit earlier because the price is different from the weather forecasting or something. Is human behavior consisting on that. And we see the effect of solar, right? In solar generate in daytime. So in daytime maybe it will be a little bit more error than nighttime from my observe from my result. So for discussion, the R-square test in training process, the ANN ABC show the best performance on R-square when ABC confine the optimum weight connection between layers and bias values of ANN. The average R-square test ANN and ABC is higher than the original ANN, about 10%. So this proposed method can improve the training process. And in the forecasting process, MAE and MRE in training process, data is shown in this table. So we can see the summation of ANN and ANN ABC is less than only ANN. If we see the summation, maybe someday ANN can show the better result, but someday ANN ABC can show the better result. So in conclusion, like ANN and ABC were trained use an 8 weeks historical data of demand and price. Apply ABC to ANN, ABC will optimize connection weights and bias between neuron in ANN structure to improve the R-squared test. Apply ANN and ABC can reduce or summation or the total error of forecasting during the forecasting period. The higher error in forecasting periods occur, it will be some price spike during the forecasting period. So recommendation of my future work, like in the predicted electricity price are evaluated by R-squared test, MAE and MIE to find a suitable forecasting model on the price forecasting of different characteristics of the such as like a number of price spike, the how volatility in the price. ANN and ABC is based on artificial intelligence approach. So every single result of the calculation is vary. So maybe we have to run and find maybe 10 times to find mean and or SD standard deviation of the result to prove their performance again. Since ANN and ABC has an excellent performance to turning on the forecasting model to match with the trained data, the methods can use to forecast a change in price or a change in input to how much is effect to the output. Okay, thank you.